Hello everyone, my name is Jigyasu and I am the Vice President of the Data Science and AI Club at the National Institute of Technology, Agartala. This video is part of the Board of Technical Council's Winter School of Technical program, and today I'm going to talk about the gradient descent algorithm. So, yeah, let's start with it. Introduction to gradient descent. Gradient descent is like one of the most important optimization algorithms that is used in machine learning. And before we dive in, I just want to put a quick disclaimer that this video is not focused heavily on the mathematics of gradient descent. To go deeper into the math, there are excellent resources available online. Instead, this video is just meant to provide you with an intuitive understanding of gradient descent and maybe motivate you to explore it further. So let's begin. Imagine you're on a treasure hunt, trying to find gold hidden somewhere on a hill. As you climb to the top and discover the treasure, the weather turns foggy. You can no longer see the surrounding landscape clearly. You only see fog. And you can also see the ground immediately around you. Like if you're standing somewhere, you're seeing the area just next to you, but not the farther landscape. Now you need to go down the hill to return to the valley below and reach your home, right? What can you do in a situation like this, when you don't have a clear view? The best approach is to take small steps in a random direction, and after each step, you check whether you are moving downhill or not. And if you are, you continue in that direction, and if not, then you move back and try a different path. By repeating this process step by step, you eventually make it to the bottom of the hill. And this is the basic intuition behind gradient descent. Taking incremental steps guided by local information. You are just using the local information to move ahead slowly and you reach the lowest point, which is also called the minima or minimum. So now I'm going to talk about how it works in a bit more deeper manner. So gradient descent is very crucial for training machine learning models. You might have heard of the term train a lot. So what do we mean when we say that we are training a model? By saying that, we mean that we are optimizing the model's parameters or variables to minimize the error between predictions and actual values. This error is measured by a function called the loss function or cost function. And the loss function varies depending on the use cases. Like for one algorithm it can be different and for the other it can be different. But typically it calculates the difference between predicted and actual values. For example, if you're working on a prediction task where you have to predict the price of a house, you'll predict some value of the price and there will be actual value of the price. So when you will subtract them, you'll get an error. So this error is measured by the loss function. So the goal of the gradient descent is to minimize this error. And mathematically, this process involves repeatedly adjusting the model parameters, or you can say variables, to reduce the value of the loss function. Here's how it works. So define a loss function. For example, let's call it g of w. And w is basically a variable or the parameter. And this loss function depends on the model parameters or variables, which you can see right in the slide. For simplicity, I'm just taking an example where loss function is dependent on a single variable w. It can be dependent on multiple variables as well, but I'm just taking an example of simple variable. So we first need to define the loss function. Let's call it j of w here. And w is basically the variable or the parameter on which the loss function is depending. So for simplicity, I'm just going to take this example where loss function is dependent on a single variable w. It can be multiple variables as well. And in order to minimize the loss function, we need to update the parameters repetitively using this formula which is given on the slide, where we update the value of variable w, and we do it by using the value of old value of variable w minus alpha times the gradient of the loss function. And gradient is basically the tiny change in the loss function with respect to the tiny change in the variable w, basically the derivative of it, or you can also say the slope. And here alpha is the learning rate, which determines the step size. I'll talk more about the learning rate soon. If you remember my treasure hunt example, you'll appreciate how this process exactly mirrors it. The gradient tells us direction to move. If the gradient, or let's call it slope, as I said previously as well, if the slope is positive, we decrease the value of w, and if it is negative, then we increase the value. This is why there is a negative operator there in the formula. It doesn't let you go in the upward direction instead of going downwards. And now let's talk about the learning rate alpha. Think of it as a number of steps you take in a direction. Keeping it high means you'll move faster, and keeping it low means you'll move slower. And I'll talk about why it's not a good idea to choose very high or very low learning rate further in the video. Now let's move on to the challenges of gradient descent. So first we'll talk about local minima. The algorithm might get stuck in a shallow valley instead of finding the global minima. As you can see in the diagram, suppose there is a minima and your algorithm thinks that this is the minimum, most like the deepest point, because when it moves forward it just goes upwards. So it thinks this is the perfect point and stops there. However, it might be possible that it is not the global minima, it's just a local minima, and there can be a deeper point somewhere else. So this is one of the challenges. And then there is learning rate. Suppose if the learning rate is too small, the algorithm will converge very slowly. Like you'll be taking steps very slowly, so you'll reach the destination really late. So this is the disadvantage of keeping the learning rate too small. And what if it's too large? So if the learning rate is too large, you might overshoot the minimum. So suppose you are supposed to take 2 steps to reach the minimum, but your learning rate is 4 steps. So when you move forward in the direction and you take 4 steps, you cross the minimum point and you move ahead in a further direction, in an upward direction. So that's not also very optimum for your task. So you need to test different learning algorithms, different learning rate, to see which one fits your algorithm best, and it can only be by trial and errors. Now we are going to move to types of gradient descent. So there are different types of gradient descent. The one that's commonly used is the batch gradient descent. It uses the entire dataset. Suppose you have a column of 13,000 dataset. So to compute gradient, you will take the sum of errors in all those 13,000 data points, and by taking that you will calculate the gradient. So this is computationally expensive, right? Because you're using the entire dataset, but it is also more accurate because using the entire dataset. Now comes the stochastic gradient descent. It also updates parameter, but it only uses one data point. So it's faster, as obvious, but it's less accurate. And then comes the mini batch gradient descent. It uses small batches of data point, so it will not use 1 or it will not use 13,000. Suppose it will use 500 or 600 data points. So this is a sort of compromise between the batch gradient descent and the stochastic gradient descent. Now we will move on to the applications of gradient descent. So gradient descent is a very foundational algorithm in machine learning. It's used for training humble models like linear regression to complex neural networks in applications like image classification, stock price prediction, text generation, language translation, and even recommendation systems. You can take the example of ChatGPT and other large language models. To optimize them, gradient descent is like extensively used. So you can understand how important this algorithm is. At any rate, now we are going to conclude the video. And to conclude it all, we'll just appreciate how gradient descent is an incredibly versatile and important algorithm. And I hope this video has sparked your interest in exploring it further, and in a broader perspective, exploring the field of machine learning further. Feel free to ask questions in the comments or even in our WhatsApp community. Thank you for watching. Don't forget to like, share and subscribe to our channel.